So, hello everyone. My name is Ojas Save, and I am joined today by my very good friend Jason, who is from Neo4j. Jason, do you mind giving a quick introduction?
Yeah, sure. Good day, everyone. Again, my name is Jason, developer advocate here at Neo4j. I've been with the company for about 3 years, and if you haven't heard of Neo4j, we are a graph database company. So a graph data store, basically the biggest difference is we permanently store the relationships between entities, unlike a lot of other databases. This allows you to traverse the data and run graph algorithms right on your data. So yeah, if you have any additional questions on graph databases or want me to go in more detail, definitely post in the chat. Otherwise, that is me.
Perfect. I'm assuming everyone can see my slides. If you can't, there are like two tabs within your Zoom client. Just click on the option where it says Ojas's screen. Yeah, this is a quick safe harbor statement that my legal needs me to show you guys before I have any external facing presentations. So just to give everyone an idea, this project is developed by Jason and myself independently, and this is not like a core Zoom feature, and Zoom is not responsible for anything that we basically say today. Yeah, um, so without further ado, let's get started. I'm sure all of you guys are familiar with Zoom meetings, but I just want to let you know that Zoom is much beyond its meetings. We have multiple products. Again, I'm not here to sell you anything, so please, within your own time, go ahead and check zoom.us, and you can see all sorts of different products that we have. But what does that mean for all the developers? That means that for all the developers that are out there, you have a developer counterpart of all of these products that are here on Zoom. So we basically have APIs that you can use to query for the data within Zoom. So think of like getting a list of all your meetings, a list of all your users, getting a list of chat messages that are sent within Zoom chat, your phone details, or even making post operations like create meeting, create users, delete users, send a chat message, etc., etc. All of that can be performed through our APIs. Then we have SDKs, which is like you can take Zoom's core technology and use it to build your own solutions. So think of bringing Zoom meetings within your own platform or using Zoom's video technology to basically get like build your own solutions on top of that without it being meeting based. So we also have the video SDK for that. Then we also have tool to build apps, for example, apps and chatbots that interact with users within Zoom chat. I have done quite a few sessions on Zoom Teams chat, so whenever you get a time, go ahead and check some of those. And then we also have webhooks and WebSockets, which are real-time notifiers. So every time like an action happens within your Zoom account, you will get a real-time notification saying that it has happened. So for example, let's say you wanted to know every time a meeting started, meeting stopped, or a participant joined, participant left in real time, we provide that information to you through webhooks and WebSockets. So these are some of the REST APIs that we have. Like, as I said, for every single product that we have REST APIs for that, for workplace, for business services, for accounts, for a build platform. We have more than 2000 plus APIs at this point. And 2000 plus APIs are great. I'm immensely proud of all the developer solutions that we have. But at the same time, because we have all these solutions um, or all these APIs, we also have our own challenges. Like, for example, sometimes it also means like to get a certain data, we have to call multiple endpoints. Um, we do not need a lot of data sometimes. But if we, let's say I call the get meetings endpoint and I only want the meeting ID and let's say the join URL, it would still give me a lot of other fields. And of course, it's expected to behave that way, but it also gives me a lot of unnecessary fields that I do not want. And in the previous example, as I said, like if I want like multiple data, like for example, let's say I want to get a list of all the users in my account. For every user, I want to get a list of the meetings, their recordings, and all that details. I would have to make multiple API calls. And sometimes it's also difficult for me to establish relationships between two fields. Between for two different APIs. So these are some of the challenges that we faced. We are very customer obsessed here at Zoom. So I like to listen to some of the developers that are building on Zoom, and these are some of the challenges that they mentioned. So I spoke with Jason, and we decided to build this small project between us. And essentially, long story short, what we did was we took some of our REST APIs and we decided to transform it into a GraphQL endpoint using a graph database. So it solved some of the problems. Like instead of calling multiple API endpoints, we were going to use a single endpoint for query. You can request exactly the data that you need. You have a graph database for all the natural relationships, and it is efficient for data traversal. So this is what our architecture actually looked like. Essentially, what we did was we basically queried every single user that I had in my account. For every single user, I got their meetings, their recordings, their meeting summaries, their past participants, etc. And we then ingested it into Neo4j database. And that ended up serving as a GraphQL server. Jason is going to go in that with details. I'll just quickly walk you through some of the basic steps on like how did I configure the marketplace app, how did I make the API calls, and then Jason will take over from there. The APIs that we used in this demo, again, we first took a list of, like we made an API call to all the users within my account. For every user, I got their past meetings. For every past meeting, I got the specific meeting details. I got the past meeting participants. I got the meeting summary for every single meeting. And then I got recordings for all that meeting, every single meeting. Now, understand, I did end up testing this with limited number of users within my account. And of course, this data was limited. But let's say if you're a big corporation and you might have 10,000 users or like multiple users, you would have to figure out on how you would do that. And again, feel free to reach out to either of us after this session. We'd love to basically chat more if you have any of those queries. So again, this is like a quick GIF of what we did. Like every user, a user hosted a meeting, a participant attended a meeting, a user could also be a participant in the meeting, and a meeting had a recording. So let me go ahead and show you how I configured the Zoom app. I'm not sure why it signed me out. Sorry. But actually, I don't need it
Well, oh,
anymore.
just while you're doing that, I think Jerry raised a hand earlier. I don't know if Jerry, if you're still had a question, feel free to jump in
Yeah.
or post in the chat.
Feel free to post your questions in the chat, guys. Give me 1 second. It logged me out. I'm going to sign in back again. All right. Desktop. Okay. So this is our marketplace.zoom.us. This is a place where you can go ahead and create apps. Apps are nothing but like plugins. You can, again, depending on what you're trying to build, you can use a name for that, but think of them as like plugins that allow you to basically generate tokens. that will allow you to make an API call. So in order to generate a token, I will first have to create an app. So in this case, I'm going to use server-to-server OAuth app. You could choose a general app as well. The reason I'm choosing server-to-server OAuth app is because I'm just querying my own data, and it just makes it easier for me to query my own data. So I'm going to call it GraphQL test app, hit create. Once I create this app, you can see I get an account ID, client secret. These are basically the only three fields that I need to generate the access token. I'm going to give like a short description, my company name, my name, my email. Um, I'll hit continue. For now, again, because this is like a test integration, we're not going to use webhooks and WebSockets, but in the future, this integration can definitely be enhanced by using webhooks and WebSockets. We are going to call a bunch of our APIs, so I will have to select some scopes. I will select the user scope. So I'm going to go here. I'm going to basically get a list of all my users, my user summaries. Then I also need to find the meeting API. So for every user, because we're getting the meeting summary, we are getting users meetings. This is the scope that I'm going to select. Then for recordings, I am also going to select the scopes that gives me a user's recordings. Return all of the meeting recordings. I think that's it. And then I'm going to go ahead and activate my app. Once my app is activated, okay, yeah. Once my app is activated, I'm going to go back. This is again the code that oops. This is the code that Jason and I built. Again, most of the hard work here is done by Jason. I just built the logic that would make a call to all the APIs. Once I get all my details, I'm going to post it in the .env file. I'm just going to go ahead and run my code. What happens when I run my code, and you can see, as you can see, once I run my code, it will first generate a server-to-server OAuth access token. Then it is going to call my users. Then it's going to get a bunch of the details for the user for me. And then for every user, it's going to get a list of all the meetings, recordings, participants, summary, everything. This is what the data looks like, what we are sending to Neo4j. So you can see like we're getting a user. For the user, we are getting a bunch of his details. We're getting their past meetings. We're getting their participant data, their recordings, and then we're getting the summary as well. And we're going to push it to the Neo4j endpoint that Jason has built. So again, it's making all the API calls for all my users. So this is going to take some time, but I'm sure you guys got an idea of what we're doing, like how we're making the API call to the Zoom APIs and basically getting the data. So from here on, I'll go ahead and pass it to Jason.
All right, thank you, Ojas. So just wanted to bring attention to Samuel's question in the chat. So he was asking, how does this approach compare to using GraphQL and interacting directly with our MySQL APIs as opposed to this ETL to Neo4j approach? And the challenge being managing all the storage in Neo4j, duplicated data, etc. So, well, I guess I can start the initial answer for that. So yes, so you could do that approach. If you already have an existing database, you could pull it into there and then put a GraphQL interface on top of that. So here we're demoing putting it into a graph database so that downstream, right, you could aggregate from several different data sources. And because Neo4j is a graph database, it marries well with GraphQL, right? So you don't have to do a heavy lift in terms of creating a GraphQL type definition, or just the setup is generally going to be quite easy. And it opens the door to using graph algorithms and other advanced GDS type algorithms to do clustering or data analytics you wanted to do later. Now, we are kind of pulling all the data into a Neo4j instance, but you could do a trimmer version where you're just storing the relationships, and you could have the core data continue to exist in another database or still in Zoom, and you just have the IDs in Neo4j so that you're just using Neo4j for kind of the graph data. Okay, so that's kind of the short answer. Okay, so before I start, I wanted to give a shout out to one of the attendees, Will Lyon, who's a good friend of mine and ex-colleague here at Neo4j. He actually built the original GraphQL interface between for Neo4j, known as the Grand Stack. Since then, Neo4j has brought on a dedicated GraphQL engineering team, and they've produced what is called the GraphQL toolkit, which lets you easily experiment and set up GraphQL systems with Neo4j. I'm not going to talk about the toolkit today because we ended up not really using it, other than just sort of experimentations early. And hey, well, um, uh, so yes, so if you have really deep questions, or you want to know about kind of the nitty-gritty of GraphQL with Neo4j, definitely reach out to Will. He's intimately aware of all this stuff. So yeah, Will, if I say something out of turn or something not quite right, definitely post it up here. Okay. All right, what I'm gonna do is share my screen. All right, Otis, are you able to see my
Yes, I
screen
can see
okay?
yours. Yeah.
Perfect, cool. Okay, so what I'm going to talk about is, so now that OGIS has shown you how to set up Zoom and push this data to an arbitrary endpoint, what we ended up doing was creating a serverless function that just takes that incoming data and upload it into a Neo4j instance. And then the second part was just having a simple Apollo node server serve the GraphQL endpoint. Okay, so why would you want to do this? So I mentioned it already earlier in answering Sam's question, but it allows you to aggregate different REST endpoints. So not only Zoom, if you had other information you wanted to pull together, you can put that into a graph, and a graph very easily ties very different types of data sources together and makes them accessible. It's also very flexible, right? Visually, it's very intuitive, so you can kind of follow along. But because graphs are inherently flexible through the relationships, it marries well again with GraphQL, which allows you to do very deeply nested calls, so long as there's relationships between the different data points. And then lastly, it allows you to do graph analytics and sort of more advanced functions that you couldn't do outside of putting into a graph system, like finding shortest paths or clustering, page ranking. Those are all different types of graph algorithms. Okay, so again, the schema, which Ojis presented a little bit earlier. So this is a compressed representation of the data coming from Zoom, the data that Ojis is passing to the endpoint. And what we're going to do from this is we're going to take the profile data, and we're going to create a user node for that profile. And you can think of a node. So a node is like a single record, right? And a node can have different labels to categorically identify it. So a node can have several different labels, but in this case, we're going to create a single node with a user label. And then all the past meetings, the details and the summary, we're going to combine those into a single meeting node. Then the nested participants will become their own nodes, and each recording data, if there is one associated with the meeting, will get turned into a recording node. Now, with all these nodes, we're going to tie together the user that created the meeting, and we're going to record that because to host a meeting, you have to be a registered user of Zoom. Now, participants may be anonymous, so we won't know first definitively if all participants are actually a registered Zoom user, right? So, but some that we do know, we can tie that together. So we can say a user who's a known Zoom user, and we can tie them to a participant who may or may not be anonymous. Lastly, we will tie the recordings with meetings if there is a recording associated with it. Okay, so once the data is imported, it'll look something like this if you were to visualize it. So here, this is OJIS's profile, and we can see here these blue nodes are the different meetings he's hosted or attended. And then these orange nodes are the other users that attended those meetings. You can see here that a lot of these are tests, but you can see where just this relatively simple JSON payload, when enough of it comes in and gets parsed, you start to create a very rich sort of graph from this data. Okay, so in the sample code that we'll be posting and for our initial project, what I did was I used Cypher to import that data into Neo4j. And now that we've done this and kind of learned a few things, what would have been probably an easier thing to do was to just take the type definitions, which we do put in Apollo, but to use the mutations ability of a GraphQL endpoint and just have the original JSON payload converted into a GraphQL mutation query so that you wouldn't even have to use Cypher at all. But I'll go through the Cypher real briefly so that you know how this works if you were to look at the code. But do realize or be aware that probably our next iteration is we're going to demonstrate this in the future. Okay, so Cypher. Cypher is the query language that Neo4j has developed and has since kind of morphed into the GQL standard or graph query language. So both look very similar. But in summary, Cypher is the query language made specifically for querying graph databases. So this is a very simple Cypher statement for creating user nodes. Now, there is a create statement, which will always create a new user node. But in our case, we don't want duplicates. So we're using the merge command. The merge command will only create a new user node if, in this case, the ID is different from any existing node. So everything in the curly braces, right? This is looking at properties of a given node. So you can put, an ID, or you can even put several different properties. And if there is a match for all of them, the system will reuse that node instead of creating a new one. And then the second statement, set. Here I'm setting a dictionary payload as all the properties for that node. So if I pass the dictionary with a bunch of key values, every key will become a property, and of course the values will be populated. So this is a very fast way of setting all the properties for a new node or an existing node if you wanted to update. Now, this Cypher statement is put into a Python function call. And here, this is for adding in new profiles, right? When that data comes in from OJIS, it includes that profile dictionary. And so that's what's going to be converted into a profile or user node. So here, we're just taking the data directly and kind of parsing out the ID from the rest of the data content. And we're putting that in as a parameter, right? So the money sign here in the Cypher statement, these are variable placeholders for parameters, right? And these need to match up, right? So PID will be the PID we get from the data payload, and profile will be just the entire dictionary that's pulled from a Pydantic model. Okay, and then we just take that and we run it through an execute query command, which you just pass the query and params to Neo4j. So this is a slight abstraction, right? Because internally I'm having it call the Neo4j database that we want to send it to. But it's basically just those parameters with the query and params, and it runs. Okay, if everything's good, it'll finish. Otherwise, one sort of catch I put in here is for if the profile already exists, I just want to kind of skip past this function and go below. So in the code, this will continue and it'll basically run different Cypher statements for each node and relationship we want to create. But just know they all follow this pattern, right? We're writing a Cypher statement, we're passing parameters, run it. If it's an error, it'll stop. If it is successful, it'll just keep going in and finish adding in all the data. Okay, so if in the future or describing type definitions in general, one option if you wanted to do this is you can use an app called Arrows app. And Arrows app is a free app for doing graph data modeling. And so what I did here is I just modeled the data that we're using. And then what you can do is up in the upper right, not sure if you can see my mouse, there's a download export button. And in there, you have several export options. You can export images, JSON representation, or a GraphQL type definition, right? So if we go back here, oh, actually, I will go to just demo this directly. So, so here, if you use labels, so any label will be used as the kind of the GraphQL name of this object. And I believe just use a single label. I'm not sure if it'll work with multiple labels, though Neo4j will support multiple labels. And for the properties here, you just add in the standard GraphQL properties, right? So if I were to do like some sort of number, right, like lat, you would do float for a optional float, and then # for uh, it being a required property in GraphQL. Okay. Now, so again, if you click on the download export button, you have these various options. So you could use Cypher actually to push this up, but in our case, since we want to get a GraphQL endpoint up quickly, pulling the type definitions can be done here. Okay, so back to okay, so last part of this setup is the Apollo server. So the Apollo server just needs a single index.js file. We don't actually need multiple files to run this. So two halves, right? The import statements and then pulling in the Neo4j credentials that we need to point to either, whether it's a local hosted instance of Neo4j, the username and password with read and or write access. Type definitions then posted here as a constant. And then when we go below, we're going to instantiate the Neo4j driver, where we'll pass in the URL and the username and password. And if the connection is successful, when we run the main function, what we're going to do is we're going to grab the GraphQL schema from the database based on that type def and driver. Now, there is an option, should be also in one of the branches, where you don't have to pass the type definitions. So if the ingest happens first and is successful, the database will have a schema on that imported data. And so the Neo schema can pull just from whatever's existing in the graph database. So you can spin this up without having to do a type definition and just have it automatically pulled as an option. Okay, so in our case, though, we're passing it explicit type definitions. We'll turn on the Express app and then the Apollo server. And for the server, we'll pass in that schema that we retrieved, pass it in. I'm going to allow introspection to be enabled so that we can use Postman to very quickly test this. Start the server, and then next step would be just to enable it. And this is used for, or makes it allows it to be run in a Google Cloud Run instance, which is what we ended up doing. Okay, so now in Postman, let's go. So what we have here is I'm connected to that cloud function, and here Postman has this great introspection feature, right? So instead of loading the type definitions, I can just introspect it and then immediately start querying. Well, as soon as it finishes loading. So here we can see we have a bunch of automatically created queries and mutations. Now the Apollo server can be set up to do read-only, so that is an option. In our case here, I kind of pre-selected, like, let's pull some meeting data, and I want the nested participants attended here. And we can see here, this is what the GraphQL query would look like. And if I were to run it, no, I ran it earlier. And this is the GraphQL data we would get, right? This nested meeting data. And so, yeah, so you could use Postman or, of course, whatever, post call you want to do later to grab this data. Okay, so that is all the key parts here. Okay, I guess I'll leave this up. Any questions?
Guys, we have already built a logic for this over here. So it's available on my GitHub. So if you guys wanted to just go ahead and take some inspiration, you can definitely check out the GitHub URL that I've posted. And if you have any questions after that, like, hey, how do we build on top of this, or how do we use this? I will be happy to walk you through. Just reach out to me via email or anything. And yeah, we'll be able to answer any questions. We'll be able to happy to answer any questions. We have one question, Jason.
Mhm.
Are mutations referred to queries in general, or
Oh, okay. So in the GraphQL parlance, right? So a query is basically like a get or a read. So if you're just doing a query, you're grabbing information from the database. A mutation is a write
post
equivalent, right?
operation?
A post operation, right? So if you want to update or add new data, you would use a mutation. Right, so that's why I was mentioning earlier, since we already added type definitions to the Apollo server, originally just for query, but with the type definitions, you can also run mutations. So this whole process becomes easier if we just take your incoming JSON payload and convert that to a GraphQL mutation. And then, no one has to tweak or modify the Cypher queries, right? You don't even have to use Cypher in this case. Okay, up on the screen, if you guys can still see my screen, I put up a QR code for a kind of a link of links. So this should have both Ogis's and mine's LinkedIn and links to all the repos and docs that we mentioned on our talk. Um, and also I put in a link to, so Neo4j, we run monthly a developer raffle for a DJI drone. So if you would like a drone, definitely click on that link and sign up. And at the end of each month, we'll do that drawing.
Yeah. And one more thing. So right now it just gets basically the past data from your Zoom account. So like all the past meeting, all the past participants, but there is like, if you go ahead and see my code, there is like one more file in that where I've implemented a webhook. The only thing I've not implemented in the webhook part is like every time you receive the data, it pushes it to Neo4j. So that is something that you can definitely choose to do as an enhancement to this project. So like, let's say if you're already using Zoom APIs and you're like, okay, I want to get my own customized data, you can definitely refer to the GitHub library that, Jason and I have built. And then you can also choose to implement webhooks or WebSockets in that, so that every time a real-time event happens in your Zoom account, that data is updated in Neo4j and you don't have to make an API call for that. Yeah. I mean, essentially, if you had to make an API call every time to update your data, it would defeat the purpose of what we have built here. So yeah, that's one more idea over here.
And this will actually get easier with Neo4j. So right now you would have to spin up this independent Apollo server. But in 2025, the team will make enabling a GraphQL endpoint from a Neo4j instance automatic. Well, not automatic. You would have to enable it. You can actually do that now, but it's a bit of a process to go to the configuration and turn it on. So the team is adding in a UI capability, so you can just like click like, hey, turn on a GraphQL endpoint for my existing hosted Neo4j Aura instance. So definitely keep an eye out for that. As soon as that is made public, I will definitely we should definitely do another one of these to show how this process iterates and becomes easier.
Absolutely. Do we have any more questions? No.
Let's see. Will, if you're still on, is there uh, did you have any questions or any interesting insights you'd want to pass on to other folks?
Well, you should be able to talk.
Cool. Hey guys. Yeah, no, it's fun to see this demo, and I like the examples of pulling in data from other APIs to expose that through Neo4j. I mean, I think that's one of the benefits of the graph, and I think something you see in GraphQL a lot, right, is wanting to be able to, I don't know, like federate different data sources. I'm curious though, like what so like LLMs and like model driven development is really the focus right now. I'm curious if you were thinking of how would you incorporate models or LLMs either into this demo or like into the like Neo4j GraphQL functionality also. Like I think vector search is exposed through the generated GraphQL API, but I'm curious like if there any thought on how you would have like a model or interface or something like that through GraphQL, if that makes sense to do with Neo4j. What do you guys think about that?
Funny you should ask that because Jason and I we presented this at our previous Zoom meetup, and I think Jason we got the exact same question from someone else over there as well. Correct?
Yeah.
I don't know if you
Yeah.
remember.
So this is definitely a future iteration we want to do is show how to kind of import this data and then kind of do a graph rag system, right? So we would have to modify the import process to include running it through a model to either pass some like, so if there's a property with like really dense text data, right, that'd be a great use case for turning it into a vector embedding, or for extracting additional entities and relationships. And then on the tail end, right, making that available to a graph rag system. Now, so I haven't looked into GraphQL using GraphQL as a RAG like sort of import or input process. It sounds like you have, Will. So if that capability is around, then yeah, that would be the next logical step to kind of extend what we've started.
Yeah, I mean, so the reason I ask is I just started working like a month ago at a startup called Hypermode, and we're building a like an API framework that leverages GraphQL and kind of providing a model interface. And so like we generate a
Yeah.
GraphQL API and we expose the model interface to like to the developer. So you're basically like writing functions, and then we take those functions and generate a GraphQL API. And so we have like the building blocks for building these like agentic API features. You can pull in data from like lots of different data sources and things like that. So I'm just starting to think more and more about how do we use AI LLMs in a GraphQL world. And I
Right.
think you're right that like as a data source for RAG for providing richer context to your models, I think is the thing that immediately makes sense.
Yeah, no, that sounds super cool what you're working on. That's and I think that might be a future joint presentation. Oh, just we might have to do a
Yeah,
pull
we
Will
can
back
definitely
in.
on that.
For, for, for sure. Yeah. I got Neo4j working with it, by the way. I'm working on like a GraphRag example with Neo4j vector search in Modus, our API framework. So should be fun to play with.
Nice, cool. Oh, and for those who aren't aware, so we kind of mentioned RAG real quickly, but RAG stands for Retrieval Augmented Generation, and it's a technique for pairing LLMs, Gen AI LLMs with databases so that you can have a Gen AI system make use of private data.
Oh, and
Cool.
guys, I quickly also wanted to mention something. So if you guys don't want to play around with your prod level Zoom data, like some of you guys might be working in like big enterprises, and you don't want to basically like test something like this with your prod level data. What I've done is, again, I've built it on my personal capacity, so please do not hold Zoom accountable for this. But I have actually built like this endpoint, and I can share it with you guys. So think of this URL on render, it's hosted on render. So think of this URL as like your api.zoom.us URL. And you can basically query some of our endpoints using that. And what it will do is it will return you a mock data. So just put like any random token, because again, this is mock data, it's send, and it should send you a response back. I'm assuming people are seeing my screen, right?
Yes. Yep. I can see yours.
So yeah, just append the endpoint, like whichever endpoint you want for this one. Also, I'm not sure why it's not responding right now. Let me try again. Get /user/me. I have absolutely no idea why this did not respond, but essentially it should just get you some dummy data from Zoom. Not from Zoom, sorry, some dummy data, but the payload will be very similar to what we have at Zoom. So again, if you don't want to like basically test with your regular production version of the data, you can just use this endpoint. Let me see. I'm not going to test. I'm just going to use like a simple. Okay, yeah, here you go. So you can see like the data will be very similar to what you get from Zoom. So like users, if I do like user/me, not user/me, my bad. I will have to use like one of the actual users that are generated. So like, for example, this, and then if I do like, for example, meetings, it should return me a list of like random meetings for the users. So yeah, go ahead and play around with this. You can even use this to ingest your own data, and I'll go ahead and put that endpoint for you guys to test with. Yeah.
Cool. Thank you. I'm going to post a link to another repo I did. So I'll update the link of links as well too. So this link is, so I can find the Zoom window again. Where am I? Oh, here we are. Okay. So this is kind of an iteration on this original Zoom GraphQL endpoint. So one of the branches includes so additional options that you can put, like you can enable read-only from just the environment, and also includes how to set up basic auth, because you should have some sort of security on your endpoint, right? Especially if it's talking to a database, even if it's just kind of for experimentation. So, OAuth 2 definitely the way to go, but at the bare minimum, use basic auth just to protect it from any sort of random person hitting your endpoint. Is 404. Oh, which one? The mock APIs for testing on render? Let me try
Yeah.
that.
It's actually an endpoint. It's an API endpoint. So you would append like your endpoint to it. So like, for example, this or this/user. So you could do something like get something like this, and it will return you some dummy data. If you're looking for the logic behind that endpoint, like how I built it, you can look at this other repo in my GitHub. So it will give you an idea on what that is. Again, right now it just queries your users, meetings, and recordings. But you can, of course, add more endpoints to that in the future. So yeah. I don't think we'll have more questions. So this was great. Thank you, Jason. I know Jason has been really busy. He's been traveling all over California, if I'm not wrong. Um, and yeah, so thank you so much, Jason, for taking out time from the busy schedule. And yeah, guys, if you have any questions, you know where to reach out to me, or if you want to reach out to Jason, feel free to get connected with him. And yeah, would love to know what everyone's thoughts are after this webinar. So feel free to reach out to us. Thanks, guys.
Thank you, everyone.